Hello. All right, this math lesson is geared towards dividing negative and positive decimals. I think that we're pretty clear on the rules for multiplying and dividing negative numbers, but now we're going to throw it into decimals. So this might, more than anything, be a review of how to divide decimals. And so my key ideas for today are going to focus around the rules for dividing decimals or the process. So when you divide decimals, a little math vocab for you, you have to make sure that the divisor, that's the number that's outside of the decimal house, is a whole number. So what do I mean by that? Oftentimes when we do long division, we'll write it like, just making up numbers, write it like this. Kind of looks like a house. People call this decimal house division, some people do. We want to make sure that the divisor, that's the number that's on the outside, is a whole number. And if it's not a whole number, we need to make it a whole number. So let's say, for example, this was 3.2 instead of 32. That is not a whole number, so we need to make it a whole number. And to do that, just move the decimal over as many places as it takes to make it a whole number. So in this case, I would need to move it over one time to make it 32. However, there's a big but here. Whatever you do to the divisor, the number on the outside, you have to do the same thing to the dividend. That's this number on the inside of the house. So if you're going to move the decimal point once for this number, you also have to move the decimal point once for this number. So in this made-up example that I have here, the decimal would be at the end of the number because it's a whole number, 147. And so I would need to move it over to the right once, and I would have to add in a placeholder 0. So this would actually become, if it had been 3.2 and 147, it would become 32 and 1,470. Now, if you want, you could type both of these problems into the calculator just to double check. They're going to get you the same answer. Moving the decimal over, as long as you do the same thing to both numbers, it will always yield the same answer. And we move the decimal over so that we have a whole number on the outside, so we don't have to do anything funky. We don't have to think about how many times can 3.2 go into 4, like that's a little crazy. Now it's 32 and we can deal much easier. Anyways, it's much easier to see this in practice, so let's do it together. First, I hope you remember how to rewrite a problem using the decimal house division. The first number is your dividend. That's the number on the inside, so I'll write that down. And the second number is your divisor. That's the number that's on the outside. So this problem in particular would look like this. Negative 8.4 divided by negative 3.6. Now, we have negatives. I didn't really need to write those in there. We already know our final answer is going to be positive because a negative divided by a negative is a positive. So I already know final answer is positive. Now I just need to do the actual division. First thing I'm going to do is I'm going to move the decimal over once to the right and once to the right here, because whatever you do to the divisor, you must also do to the dividend. I'm going to rewrite the problem so it's a little clearer, and then we'll solve. So this is a 36, and this is now an 84. And I'm just ignoring the fact that they're negatives because we already know our answer is going to be positive anyways. Okay, how many times can 36 go into 84? It can go in twice. 36 times 2 is 72. And then you subtract. We're going to get 12. And there's no 0 to bring down, but if I add a decimal, this will keep it as an 84, and I could call it 84.0, and now I have a 0 to bring down. Also, now that there's a decimal in my dividend, I need to bring it up into my quotient so that I have a decimal in my quotient. All right, how many times can 36 go into 120? It can go in 3 times. 36 times 3 is 108. And when I subtract, I get 12. I'm going to add another 0, bring it down. And I think you can see this is a 120, and I go in 3 times. I'm going to get 108. This is going to repeat forever and always. So my final answer, 8.4 divided by 3.6, negative divided by negative, is positive 2.3 repeating. And we use that symbol to signify that the 3 is going to repeat forever and ever and ever. 2.333333333. Okay, another example. Here we've got 2 and 4/10 divided by 3.2. So that's going to look like this. 2 and 4/10 divided by 3 and 2/10. A negative divided by a positive means my final answer is going to be negative, whatever it is. And we're going to actually rewrite this because I need to move my decimal over once and once. So 32, 24. Okay, 32 can go into 24 0 times. So I'm going to try again. I'm going to add a decimal, and I'm going to add another 0. 32 can go into 240 7 times. 32 times 7 is 224. So I'm going to subtract, and I'm going to get 16. I'm going to add another 0, bring it down. 32 can go into 160 5 times, and it actually goes in 5 times evenly because 32 times 5 is 160. So there's my answer. And remember, negative divided by a positive is a negative. So my final answer is negative 0.75. All right, we've done 2 examples. I'm going to do one more. I'm going to do a word problem because I know how much everyone loves word problems. Just try to give you some perspective as to when you might see division in a real life setting. So here, a restaurant launches and a mobile app. Most restaurants have some form of this, and it lets customers rate their food on a scale of -5, meaning like, wow, don't want that, to 5, which is like, ooh, I will eat this every day. And so far, customers have given a couple ratings. They've given it a 2.25, a -3.5, a 0, another negative, a positive, so all these ratings. And the question is, should the restaurant consider changing their recipe? And why do you think so? So if we have to justify this with a number, what I would say to do is we have these scores that are kind of all over the place. Why don't we find some sort of measure that can describe how people feel in one number instead of 7 different numbers? So what we're going to do, actually that's 8 different numbers. So what we're going to do is we're going to find the mean. That's another word for the average. If we average these scores together, then we'll know at least a general sense of how people feel about this lasagna. And then we can make decisions on if we should change the recipe or keep it as is. So to find the average, you add all of the scores up and you divide by the number of scores. And there are 8 scores here, so we're going to divide by 8. And what that will look like mathematically is this plus this plus this plus this plus this, the sum divided by 8. Now, we could just sit here and add all of these, but I noticed a couple things that might save us some time. Someone gave it a -3.5, another person gave it a positive 3.5. So if we add those things first, those will zero out, and we won't have to waste time with 2 of the numbers. And then I also noticed I have a couple positive numbers. So that's the 2.25, the 1.75. The 0 doesn't really count. It's not positive or negative, but I have 2 positives. So let's add those together next. And then the last thing we'll do is we'll add these 3 negative numbers. Using different colors, it's all one it's all one addition problem, but at least you can kind of see the process that I'm taking here. All right. So we're going to add everything together, and then once we get that sum, we'll divide by 8. So the first thing is 3.5 plus -3.5. That's 0, so that's gone. The next thing is 2.25 plus 1.75, which is 4. And the last thing is -4.5 plus -1 plus -2.5. If you add all of that together, it's -8. So I've got 0 plus 4 plus -8. basically 4 plus -8, which is -4. So this becomes -4, and remember you have to divide by the number of scores that there are. 1, 2, 3, 4, 5, 6, 7, 8, 8 scores. So -4 divided by -8 is the same thing as -1/2, or if you want it in decimal form, -0.5. So overall, people have given this lasagna a -0.5. They didn't even give it a 0. It's less than a 0, which means it's probably not too great, though there are a few people who seem to like it. And I think if I was the restaurant owner, or if I was advising this restaurant owner, I'd say they should probably look into tweaking the recipe at least a little bit. But either way, this is dividing negative decimals. If you have any questions, feel free to reach out. Otherwise, do your thing and have fun. Bye-bye.